Hello and welcome to Otten Math. In this edition of Otten Math, we're going to talk about problems involving regular polygons. We've got two-column proofs and one algebraic proof or algebraic problem involving regular polygons. And this is going to be part two. So we've done, in part one, we did one problem, and in part two, we're going to do three. All right, let's see. We've got number 14. A, B, C, D, E, F is a regular hexagon. It's drawn here. And we want to prove, that's what's given, we want to prove that A, C, D, F is a rectangle. So let's talk conceptually about what's happening in this particular proof. So I know that in a regular hexagon, the sides are congruent and the interior angles are going to be congruent. So let's figure out what the interior angle measure is for a regular hexagon. Well, I know that the formula for the interior angle measure for any polygon is going to be the number of sides minus 2 times 180, and this is just equal to the sum of the interior angles of a given polygon divided by the number of sides. So in this case, I have a regular hexagon. It's going to be 6 minus 2 times 180 all over 6. 6 minus 2 is 4. 4 times 180 is going to be 720. 720 divided by 6 leaves me with 120 degrees per interior angle. So again, a regular polygon, each of the interior angles has the same measure, and each of the side lengths is going to be the same. So I know also that angle FAB is going to be 120 degrees. I know BCD is 120 degrees. I know AFE is 120 degrees. I know CDE is 120 degrees, and I know that angle E is also 120. And in a regular hexagon, I know as well that the sides are congruent, so I know it's an equilateral figure. So AB and BC are congruent, and I know that if the sides are congruent, then the angles opposite them are also congruent. So I can say then that angle BAC is congruent to angle BCA. And if I know that angle ABC is 120 degrees, I know that A and C are congruent, and I know that the sum of the measures in a triangle is equal to 360 degrees, then I'm left with 30 degrees and 30 degrees for these respective angles. I know the same is going to hold true for this triangle on this side, FED. FED angle is 120 degrees. I know that FE and ED are congruent. That leaves me with 30 degrees each for EFD angle and EDF angle. All right, now if AFE is 120, then AFD is going to be 90 degrees, and FAC is going to be 90 degrees, and ACD will be 90 degrees, and FDC is also going to be 90 degrees. So now I have a quadrilateral with 4 right angles. All right, if I have a quadrilateral with 4 right angles, then I know that the figure is going to be a rectangle. All right, so let's go back to our proof, and I'll write this out as a two-column proof. I have my statements and my reasons. I say that A, B, C, D, E, F is a regular hexagon. That's given. I know that all the interior angles in A, B, C, D, E, F are equal to 120 degrees. Interior angle measure of a regular polygon is equal to n minus 2 times 180 divided by n. We figured that was 120 degrees. Then I'm going to say that the sides are all congruent. AB is congruent to BC, is congruent to CD, is congruent to DE, EF, and FA. That's a definition of a regular polygon. All the sides will be congruent. Then I know that angle BAC is going to be congruent to angle BCA, because if I have sides that are congruent, then the angles will also be congruent. So let's just mark that up here. BAC and BCA are congruent. I also know that EFD and EDF are congruent for the same reason. I know that angles BAC, BCA, EFD, and EDF are going to be equal to 30 degrees. So all the angles I just mentioned here are 30 degrees, and I can figure that out by subtracting 120 degrees from 180 and then dividing the balance of 60 degrees by 2 to give me 30 degrees for all of these angles that are marked in red. Now by subtraction I can figure out that A FD, FAC, ACD, and CDF are all going to be 90 degrees or right angles. Now I can just basically say, I say first that ACDF is a parallelogram because opposite angles are congruent, then it's a parallelogram. But really, step number 7 is not necessary. We can just go right to the proof statement, which is ACDF is a rectangle because it's a quadrilateral with 4 right angles. Now you can use this half step here to say it's a parallelogram first, and then say because it's a parallelogram with at least 1 right angle, it's a rectangle. Either way will work. And either way, we've shown that that figure ACDF is a rectangle. Okay, moving on to the next proof, number 15. I'm given a 3-dimensional figure. I have RO that's perpendicular to plane GHJ. So we're going to mark this up. RO perpendicular to plane GHJ. And so HOR is going to be a right angle, and JOR is a right angle as well. I know that OM and K are coplanar, so OM and K are coplanar. GHJ, KMP, this figure here, which looks to me like a hexagon, is going to be a regular hexagon, and that's in blue. I know that ray HO here bisects GHJ, so I know that the angle here, HOJ, and the angle here, OHG, are going to be congruent. What else do I know? I know RH is congruent to RJ. So RH, and let's mark this up, RH, and this is in the figure that's coming out of the plane, is congruent to RJ. Well, it looks like I have 2 triangles that are congruent by the HL postulate. So I see that RO is going to be congruent to itself. I know that RH is congruent to RJ, and that was given. And I have my right angle ROJ and ROH that are going to be congruent. So I have 2 triangles that are congruent by HL. Now I can also figure out what the measure of O angle OHJ is, because I know in a regular hexagon that the sum, and we did this from the last problem, the sum of the measures of all the angles, interior angles in a hexagon is 720. Each interior angle, therefore, must be 120 degrees, which means that in this case, OHJ is 60 degrees. Now, by CP/CTC, I can say that OH and OJ are congruent. So I know that OJH will also be 60 degrees. And that leaves me with only 60 degrees left for angle HOJ. So in this case, I know HOJ is 60 degrees. So if I have angles that are congruent, then the sides are congruent. So HO is congruent to HJ and OJ. So I have a regular triangle. HOJ is a regular triangle. All right, so let's go through the 2-column proof portion of this now that you understand conceptually what's going on. And this is a little bit of a longer proof. So I had to break this up to try to fit this in a page, so I apologize for some of the confusion on the page. All right, so GHJ, KMP is a regular hexagon. That was given. I know that angle GHJ is 120 degrees, and I know that because in a regular hexagon, the sum, or any hexagon, the sum of the measures of the interior angles is equal to 720 degrees, or n minus 2 times 180. And I know that there are 6 angles which are all congruent in the hexagon. So each angle, each interior angle in a regular hexagon is 120 degrees. Now I know that HO bisects angle GHJ, that's given. So I can say that angle OHJ is equal to 60 degrees, or half of 120. So OHJ now is 60 degrees, or half of 120. I can also say that GHO is 60 degrees, right? Because OH bisects GHJ. Then I'm going to say that RO is perpendicular to plane GH. RO is perpendicular to plane GH. I believe it was GHM, and that was given. So RO is perpendicular to HO and JO. And so we remember that if a line is perpendicular to a plane, it is perpendicular to every line that passes through the foot. So I know that ROJ, or RO, is perpendicular to HO and JO. That means that ROH and ROJ are right angles. That's a definition of perpendicular lines. I can say RO is congruent to itself. Let me just mark these up here. So ROJ, right angles. I know that RO is congruent to itself. I'm given that RH is congruent to RJ. So I have by HL postulate that triangle ROH is congruent to ROJ. Now we can say that OH and OJ are congruent by CPCTC. And I know angle OHJ is congruent. So OHJ is, and let's actually do this in blue. I know that OHJ is congruent to OJH because if the sides are congruent, the angles opposite them are congruent. That means that angle OJH will be equal to 60 degrees as well. And if OHJ is congruent to OJH, HOJ is also congruent to OHJ by subtraction, and those are both the two angles. So now I have a regular triangle in HOJ. All the angles are 60 degrees, and then the sides opposite them are also going to be equal. All right, moving on to the last problem. These are somewhat lengthier problems. This one's a little bit shorter. Okay, so I have, if the measure of angle E is 3x plus y plus 9, and the measure of angle A is 2x plus y minus 4.5, what are the values of x and y? Now we're given that this is a semi-octagon, and it's a regular semi-octagon, which means that the angle E, D, and C are all going to be congruent, and angle EAB and CBA are going to be, half of the angles C, D, and E. So let's figure out what we've got here. The measure of angle E is 3x plus 3y plus 9. So I have 3x plus 3y plus 9. And we're going to figure out that each interior angle in an octagon, I believe, is 135 degrees. Let's check to see if we're right. So n minus 2, the formula again, n minus 2. We learned this in the lesson, and we did this in a problem, actually last problem and the problem prior to that most recent problem. N minus 2 times 180 divided by n gives me, in a regular polygon, the interior angle measure. Okay. And we're going to figure out that n minus 2, we have an octagon here, n minus 2 is 6 times 180 gives me 1080 divided by 8 sides, and that leaves me with 135 if I'm not mistaken. So angle E is 135, angle D is 135, angle C is 135, angle B is 67.5, angle A is also 67.5. So we know angle E is equal to 3x plus 3y plus 9. That again is equal to 135. So we subtract 9 from both sides and then divide by 3, and we have x plus y is equal to, x plus y, yes, is equal to, I'm going to say 44. Let's just double check to see that we're correct. Okay, no, it's not 44, it's 42. So if I subtract 9 from 135, I get 126. 126 divided by 3 is equal to 42. So glad I'm catching this error now, which means that x is equal to 42 minus y. Now, we know that the measure of angle A is equal to 2x plus y. And we know the measure of angle A is equal to 67.5 degrees. So I have 2x plus y is equal to 67.5. Oh, I'm sorry, minus 4.5. I don't want to make these mistakes here. So I'm going to say that 2x plus y is equal to 67.5 plus 4.5, which gives me 72. And so in this case, what I can do is substitute the value that I just got for x in determining the measure of angle E in for x and then solve for y. So I have 2 times 42 minus y plus y is equal to 72. And I'm going to have to continue this in the upper left-hand side of the page. And let's do this in blue just so that you can see what's going on. So now I have 2 times 42, or 84, minus 2y plus y is equal to 72. Or I have minus y is equal to minus 12. Y is equal to 12. If y is equal to 12 and x is equal to 42 minus y, then x is going to be equal to 30. And those are your answers.